Alrighty, welcome everyone to our last session for today. Now this is it is the last session. I know everyone might be a little bit tired, but just before I do introduce the session, if everyone could just make sure they have the Summit app downloaded, just because that's where we get feedback for all of our speakers. And also just as a courtesy to other audience members, if we could just keep our phones on silent, that would be great. Now, to introduce the session today, this is a level 300 session which is focused on simplifying Kubernetes workloads with Karpenter and Amazon EKS. So, to describe the session, I've been told, how many of us have ever wished Kubernetes could just work? Well, today they'll show you how you can make it that simple. I'd like to introduce Frank Fan to the stage.
Hello, everyone. Let me introduce our friend, John. He's an overworked platform engineer looking after a business-critical Kubernetes platform. His typical day involves wrestling with scaling challenges in the morning, dealing with upgrade failures in the afternoon, and then being woke up at night for urgent security patches. People nodding heads. What would be ideal word for him? Application always working at optimal performance. He doesn't need a PhD to operate Kubernetes cluster. Security is job zero, and he still have a good sleep. Let's talk about some challenges in this session and share with you some core capabilities about our new service, EKS Auto Mode, to help you. Let's start a bit of journey about EKS. Prior to EKS, people need to self-manage the control plane. You need to worry about high availability, security, resiliency, all the stuff. EKS is a way for you to delegate this task to AWS. We manage control plane on your behalf, provide secure and trust environment. The architecture is simple. On the top, you have control plane. We manage that for you. At the bottom, you have compute node, where you are going to deploy your applications. Quite simple, isn't it? What if you want to onboard a business-critical application in production? There are a lot more for you to consider. Left-hand side, still the same control plane. Don't worry about that. But in order to get your application working, you need to worry about how I'm going to scale. How about load balancing? How about the storage and networking? And beyond that, you need to think how I'm going to provision. Do I self-manage? Do I use EKS add-ons? Regardless which way you are going to use, you still need to maintain compatibility and upgrade and ensure they all together working perfectly. It's not a trivial task for lots of customers. Beyond that, you all need to look at the life cycle of the computer nodes. We heard customer feedback, and we want to make it simpler. That's why last year, at re:Invent, we announced the new feature, EKS Auto Mode, going to automate lots of heavy lifting tasks for you, and you just focus on your core applications. Let's take a look at the change. This new architecture will basically shift some capabilities from your own managed environment to AWS managed environment. As you can see, no change about control plane, but that box next to it, these some capabilities we provisioned inside the AWS account. For example, scaling components, load balancer controller, and EBS volume driver. Beyond that, we also look after your operating system. Previously, like John did, need to keep the patch up to date. We look after that patching for you. And also, we're going to help you to automate the life cycle, not just the control plane, but also the compute nodes inside the data plane. In terms of that Amazon managed operating system, this is we call Amazon managed image. We already put lots of capabilities inside. For example, DNS discovery, port networking, network interface, and so on and so forth. If some new features come up, we simply just update this AMI, and later on you initiate upgrade of your nodes. Automatically, you can consume the latest or best feature there. What it look like for auto mode? First of all, you start a cluster, provision new cluster with auto mode, or you enable that in the existing cluster. Then you onboard the application. It will trigger the provisioning of the underlying data plane. Beyond that, we monitor your workload and decide to scale out or scale in these compute nodes for you. Last but not least, we look at the patching of your AMI and your data plane and control plane upgrade in one go. John had a problem about scaling, right? How you can keep up the backend compute nodes with your increasing demand is always a challenge. Let's jump in the cluster. I create an auto mode cluster here, pick up the Kubernetes version here, and then I'm going to create a roles for EKS cluster and node, ensure they have right permission to integrate with other AWS services, and have permission to add the node into the cluster. This is very typical settings. You can do this using wizard like this, or Terraform or CDK. And then simply click Create. The cluster is in progress. Let's jump into a cluster I already created before. So basically, this one cluster I already enabled. You can see it's active, and then auto mode has been enabled. The one important thing I want to let you to look at is what's running there. This is fully functional cluster. Surprise, nothing there. There's no compute nodes. That's strange, right? It's different from the traditional cluster. But look at here, no ports. That explains. There's no running application, so we scale the cluster to 0. That's exactly what we expected. I'm going to deploy application, a simple one with one pod running. Before I deploy it, I'd like you to look at the current configuration of the cluster by running a real-time tool called EKS Node Viewer. And here you will see what's running at the moment. 0 pod, 0 node. That's our baseline. Let's deploy this application and see what happened. From here, you will see the pod is pending because we have 0 node. This will trigger the provisioning of the backend environment. You can see one node is being provisioned. It's C6A and large node. Within seconds, the node is ready. The pod is up running. That's cool. We scale from 0 to 1. But John's problem is I need to scale quickly for more workload. How about scale to 10 pods? Let's see what happens. And here, we just change the replica to 10. And then you can see the pods pending. 9 of them are pending. But very soon, it triggered provisioning of a much larger node. You can see this is 4 times larger than previous one. Why? Because we know you have more workload. We want to be efficient, give you a bigger size node to accommodate all of them. Very soon, the node will be ready. All 9 pods will be running on this newly created node. But now we got a problem. You have 1 pod running on the old one, and 9 of them running on the new one. You have lots of empty space in this old node. Don't worry, we cover that automatically without any human intervention. And then the scaling mechanism will kick in to the assessment and then evacuate that 1 pod from the old node to the new node. You will see this 1 node will accommodate all the 10 pods perfectly and terminate that old one. So that way we consolidate your compute and also provide optimal performance. So here we go, 10 of them are running perfectly. You may wonder what happened under the hood of this solution. First of all, the magic is the backend. We have wide range of instance types. And it depends on workload. You may want to have a memory intensive or compute intensive or storage intensive workload. We have that covered. You can also choose different capabilities, different architecture for CPU. You can also choose Graviton instance and choose the way you purchase, on-demand, or savings plan, or spot to save your cost. What's happening underneath is we group these compute resources as logical group we call node pools. By default, you have general purpose and system node pool. But you may ask, I'm special, my customer special, I have special need. We got that covered. You can use the define node pools. For example, I have an inference workload. I can specify a specific instance type. In this case, inferential 2 for this workload. I can span across multiple AZs. You can have flexibility and control of the setting. In a demo, you can see within seconds, you can get the scaling very fast. So traditionally, that's how scaling works. In industry, using cluster autoscaler and talk to auto-scaling group, and then talk to EC2 fleet. There are 2 challenges of these settings because 1, every time when you scale out, it always uses your existing instance type. It cannot dynamic change. Secondly, you can see middle components rely on auto-scaling group. With Karpenter, you can do that in a very smart way, automatically assign different instance type, and you bypass these middle components and talk to EC2 Fleet API directly. That's why within seconds, you can get that backend compute node ready. So in this situation, you have pod running on 1 node, lots of empty space. Karpenter will assess your current utilization and then your request of the resource, and then simply consolidate them, make it more optimal experience for you. And also same time, save the cost. I just covered about the challenges that John had, the first one. Still have 2 hard questions need to be answered. Let me introduce my colleague, Faisal, to help with the rest of the challenges. Hand over to you, Faisal.
Thank you. Guys, thanks, Frank. My name is Faisal. I'm working again as a startup specialist for containers and app mod domain. And we're going to continue off the story that Frank has started is when you are running Kubernetes cluster, our North Star is to make sure that you have time to do higher value work, to innovate faster, to be more agile. And we want to take as much as heavy lifting on your behalf. So you can see here, the first one, we actually improve the cost and efficiency of your cluster by making the right selection for your cluster. Now the second thing that we want to discuss here is simplify the operations, because the first part we show is we give you the right hardware. Now what we can do in the software stack that can help you be more agile, that can help your platform team do more higher value work instead of just thinking about how to patch or how to scale better. So before that, see, I define our lives as two eras, maybe pre-EKS auto mode and after EKS auto mode. So this is the pre-EKS auto mode era life. And if you can see here, when you have managed node group, so think about into two major dimensions. The first dimension is you can see the second row from the top, which we call cluster EC2 instances. So once you, before the EKS auto mode, when you want to provision a new node, you need to worry about not only the node, but also running the operating system on the node. So you need to worry about patching the operating system on the node, or if you're using specialized hardware such as NVIDIA, you need to worry about the NVIDIA special software stack is available on those nodes. True that we have an AMI, but you have to find the right AMI with the Kubernetes version and so on. So that's, I would say, the first dimension of simplifying operation is running the EC2 fleet of your data plane. The second dimension of your operation is once you have the operating system available, you need to configure different components of your EKS cluster. That's the third row from the top, what we call it cluster capabilities, such as networking using CNI, such as storage, such as load balancer. So all these things you used to do in the previous life is using add-ons, like you have a load balancer controller, you have a storage controller, and different add-ons available for that. So the problem with that is you need to always think about how you are going to patch the add-on, and if you upgrade, you have the right version of add-on with you. And the last but not least is on the top right corner, the first row and the first column is system agents, right? When you're running the EC2 instances as your data plane, you need to worry about container D, you need to worry about kubelet, and so on. So all these things add the complexity of John's team, add the complexity from the platform team to worry about, okay, if we upgrade, any of it may fail, and then people don't do upgrades, and then people go to extended support, end up paying us more money. Although we liked it, maybe we don't mind it, but still, better is to what about you use the right setup for your right EKS infrastructure, right? So what EKS Automos does is, you can see here, we simplify to that level. Now our North Star was, remember when I mentioned, is you focus on building application and deploying and running application. So now what the flow would be, hey AWS, give me an EKS cluster, here's my VPC, and okay AWS, now start deploying the application. The operating system on the EC nodes, EC2 nodes, the cluster components of Kubernetes, and all the agents will be managed for you by AWS. So as Frank shows before, the hardware is scattered. Using EKS Auto Mode, you select the right hardware, and also the software layer on that hardware is also catered for you, so that you can move faster and John's team can do better work. So let's do one by one into the two major groups that I talked about. One is the EC2 instances, and the other one is the cluster capabilities. So the first capability that I want to do a bit more deep dive is called networking components. So before that, if you're running EKS Auto Mode, you have to install Core DNS add-on, right? And a lot of customers can say, it's a headache to make sure that you have the right version of Core DNS add-on. You may need to have a upgrade and patch the add-on as the new version comes through. So that adds the challenges of managing the cluster. Similarly, one more challenge we see in the Core DNS is a scaling problem. For example, if your cluster going from tens of nodes to hundreds of nodes to thousands of nodes, sometimes Core DNS actually add latency in finding the service. So when we manage it for you via EKS Auto Mode, we actually give you the right version, the right scalability, and simpler operations for your EKS, for your all EKS nodes. The second add-on that we cover is VPC CNI. So of course, by default, we use install VPC CNI for you. So one of the practice what we do is we give you the right out-of-the-box sensible defaults. For example, network policy is already enabled. And similarly, we give you the right container D, we give you the right kubelet, so that you don't have to worry about when you upgrade the cluster, when you start the cluster, when you scale the cluster, and when you need to patch the cluster. So all these things are not running as pods. They are running as system D services in the EKS auto mode, right? So the benefit of that is we actually own, because we actually own the operating system, so we run components there. So it gives you better outcome with better scalability and better tight integration with the operating system. So these are the networking layer for the cluster capabilities that we automated for you. So don't think of that as simple add-ons. As I mentioned here, you need to worry about patching, you need to worry about scaling, you need to worry about matching the right version with the right Kubernetes version. So all these complexities taken care for you by EKS Auto Mode. The second part of networking component is called load balancer controller. Are you guys aware of load balancer controller, or it's a new thing for you? Yes, no? Seems like lots of people are nodding. So it means like if you want to expose your services outside your Kubernetes cluster, you can use load balancer controller. In the EKS auto mode, we also take that responsibility on to AWS. We run the EKS load balancer controller in our VPC, and it actually watch all the resources that you require and provision either the NLB or provision either the ELB. So once you provision a cluster, as Frank shown, using EKS auto mode, you are just ready to use ingress and services as we go. And the middle layer, the management and operation part, is taken care for you by AWS. So you can see one example here. When the cluster is configured in EKS, you use EKS service and use the load balancer controller to actually provision an NLB for you. Similarly, if you are using ALB, then you can use ingress, which is a Kubernetes manifest, and it will automatically deploy the ingress for you. So from provisioning the cluster to deploying the application, we actually shorten the complexity and improve the agility of your team. Once the cluster is available, you can start deploying ingress services onto your cluster. The third part I want to discuss in the cluster capability, so we discussed networking, we discussed load balancer controller for your applications. The third part is what called storage. So once you're running application, if it's a useful application, chances are it needs some sort of persistent store. So we have lots of storage capabilities like EBS, EFS, FSX, and Kubernetes allow you a thing called CSI, storage interface, where it can talk to any storage provider. So before EKS auto mode, you have to install that EKS provider for CSI for EBS, for example. So that's also taken care by us now. So we run the controller in our account and actually run the agents on individual nodes to provision the volumes on your behalf. So as a developer, once the EKS is available, the John's platform team provision the EKS, tick the box of EKS auto mode, and immediately developer can start using it. They don't need to worry about installing the right add-ons for storage also. So for EBS, we actually give you the capability to start fast, move fast, while we take care of security, patching, and upgrades. EKS auto mode, we are adding so many capabilities. Sometimes you may think, hey man, like it's maybe deviating from our promise of fully upstream compatible. So it's not. EKS auto mode is fully upstream compatible, right? For example, there are lots of other storage services that AWS provide, like FSX or EFS or S3, for example, that also work. It doesn't come out of the box from auto mode, so you still use the old ways of provisioning this CSI onto your cluster. So EKS auto mode is fully upstream compatible, but we give you benefits of simplified operations and improving agility for your team. You may ask, I talked about two groups in the previous, in the layer picture, operating system and the cluster capabilities. But I have not talked about operating system, right? Because we cover it into the third dimension of John's team. It's called improved security. So you see, when Frank talks about EKS, he talks about bringing the right machine. So that's a hardware. And I just talked about bringing the right cluster capabilities like networking and storage. But in the middle, there's an operating system that's running on EC2 instance. So what AWS does, we create a new operating system called Bottle Rocket. It's a container optimized operating system. What does it mean? It actually reduces the number of operating system packages that comes into Linux to reduce the blast radius area of your operating system. It's read-only. It has enhanced SC Linux. So we give you secure by default, the most secure option for your operating system to run on EKS. So right now, from actual machines, EC2 instances, to operating system, to Kubernetes components, all of them is covered for you by EKS Auto Mode. We not only give you the right operating system, but we also patches the operating system for you. All the patches that come for that Linux operating system will be automatically patched by our EKS Auto Mode. So add-ons patched, machines patched, and Kubernetes system agents and containerd are also patched for you by AWS. The last but not least is called drift detection. So as Frank talks about control plane and data plane, right? So once we talk about versioning upgrade, you can see that in the EKS Auto Mode, before EKS Auto Mode, you start to, when you start to upgrade the EKS cluster, you want to start upgrading the control plane first, and then you go update the managed node group and update there, right? With Auto Mode drift detection capability, what it does is once you start a major version upgrade, let's say from 131 to 132, you start it, so still you are in control, but you start with a one single API call. It will upgrade the control plane as usual, but the drift detection will detect that the control plane is 132, for example, and your managed nodes are still on 131. So still start to apply automatic patch upgrades for your Kubernetes. So that's a huge, huge capability, especially if you are running more than few clusters. To automatically upgrade is still controlled by you, but you can use our capability via Auto Mode drift detection to upgrade the whole cluster as you go. But I'm lazy. I'm saying, okay, so a customer, so EKS upgrade happens once every 6 months or maybe a year, depends on the situation. But there are a lot of security patches that comes every 3 weeks or every 4 weeks. I don't want to go there and install, start that manually. So we hear you that feedback from customer, and we find out if you're running, if there's a minor version upgrade for the same version of EKS. For example, in this example, let's say you're running version 130. Let's say you have 2 nodes running, and there's a patch release for 130. Still, the main version is 130, but there's a patch release, right? So what EKS Auto Mode does, because we own the operating system, we own the hardware, and we own all the Kubernetes cluster components. So we say, aha, there's a new version available with a new patch software stack. We find it automatically that the new components is available for you. And then it automatically start replacing your node with the newer version. So that's fully automatic without any intervention from your team. So John's team now don't need to worry about immediate security patches that's released by Kubernetes upstream or AWS. They are aware that all the latest patches will be applied automatically as you go on the EKS. So you can see here now the operation of the EKS Auto Mode is simple now. Is you provision the control plane with the EKS CTL or Terraform or CDK API, and then you can start deploying the applications. In between, managing the operating system, managing the cluster components is all taken care by EKS Auto Mode. Okay, so I think that's what I talked about is provision the Auto Mode and deploy the applications. That's our ultimate North Star, is provision the cluster and deploy the application. Everything in between, and there are a lot of things I mentioned here, like there are operating system, there are application components, there are cluster components that all are taken care for you by the EKS Auto Mode. So what are the realized benefits for John's team? Is the number one is optimized performance and cost, as Frank's talked about. We bring on the right hardware, and we are continuing to optimize that. We give you simplified operations for operating system patching, for enhanced cluster components patching, like load balancer controller, like add-ons, like storage controller. And we also bring on better security with a specially optimized bottle rocket and optimal automatic patch updates on the minor version. So John's team is happy now. They can do more and more higher level value work that brings on agility and innovation for your business, and the heavy lifting is done by EKS Auto Mode. So you can learn all about, there are other blogs available, there are documentation available. Frank and I are also available to help you out to do that. So please feel free to come to us on that. So you can take a snapshot of this if you want to. And last but not least, please don't forget to do the survey. If you like the talk, let us know. If you don't like it, let us know why, and we'll try to improve that next time. Thank you very much.
Awesome. Thank you so much. If we could please just get everyone to fill out the feedback, that would be amazing. And I do believe there are some networking drinks happening in the foyer soon. So if everyone could just leave their heads